Hello, my name is Kody Lawler, and my project is about analyzing payoff strategies between countries competing for land occupation. My project uses game theory, and some background of game theory is that it's the study of mathematical models of strategic interaction among rational decision makers, and those decision makers would be the players of the game. Game theory emerged around 1944 from this book, Theory of Games and Economic Behavior, written by these two gentlemen. And the rules of a game are very important because they limit the options for how the game will be played. Now let's talk about terms that are specific to my game. My game is a two-person game, where that is the number of players or countries in my case. In game theory, you can go into three-person games, four-person games, and five-person games, but it's most common after five-person games to go straight to in-person games. My game is also non-cooperative, where there's conflict between the players with no communication. Imagine a brick wall between both players so they can't speak to each other. My game also deals with payoff matrices, in which there's tables with cells that show payoffs to each player. Think of those cells as a XY coordinate. My game is a constant sum game where the pair of payoffs, the X and Y inside of the cell, have to sum up to the same constant. And my game also deals with saddle points. If a saddle point does exist, it will show each player what their optimal strategy is for maximum gains of one player and minimum losses of another player. Now let's talk about the rules of my game. Number one, the total land available is 10 units. That 10 would be the constant in my constant sum game. Number two, the two players are country X and country Y. Number three, both countries have a choice to either defend the land they own or invade the other country's land. Number four, country Y always has a larger military power, so they will always gain more units on an invade choice than country X would. Number five, if a country chooses to defend, they automatically gain 1 unit from the other country. And number six, if a country's unit gain is larger than the units available to be gained, then both countries stay at the same unit amount. Now let's start to talk about what we will be investigating. So starting positions are the 11 different scenarios of the amount of land that each country will occupy, again totaling 10 units, which range from 10-0, where X owns 10 land and Y owns 0 land, to 0-10, where X owns 0 land and Y owns 10 land. Each game will have specific gains for country X and country Y. And we will investigate the number and cell location of saddle points for each starting position and combination of gains. Now let's look at an example where X gains 2 on an invade choice, Y gains 3 on an invade choice, and we're at the starting position of 3-7, where X owns 3 land, Y owns 7 land. And we can see that this 3-7 also appears down here at defend, because when X defends, we take 1 from Y and add it to X. 7 minus 1 will give you 6, 3 plus 1 will give you 4. But Y is also defending, so we take 1 from X and take it over to Y. 4 minus 1 will give you 3, 6 plus 1 will give you 7. So we can say every time we say a starting position, we're always referring to this defend cell. Now let's try to figure out how to fill out the rest of the payoff matrix from this starting position. So if we go over to y invade, x defend, x takes 1 away from y. So now we are back to a 4-6. But y wants to take 3 on an invade choice. We're at 4-6. 4 minus 3 would give you a 1. 6 plus 3 would give you a 9. That's how we fill out this one. Let's go down to x invade, y defend. Well, y is defending. We take 1 away from x and pull it over to y. Now we have a 2-8, but x wants to gain 2. So we say, okay, 8 minus 2 would give you 6. 2 plus 2 would give you 4. Now we've filled out this cell. Let's move over to invade, invade. You can see we're not defending at all, so we're not using the defend rule. So we say, okay, x gains 2. If x gains 2, 7 minus 2 is 5. 3 plus 2 is 5. We have a 5, 5, but y wants to gain 3, so x minus 3 would give you 2. Y plus 3 would give you 8. But why is there a little asterisk next to the invade, invade cell? That's because we have a saddle point. And a good way to check a saddle point is by looking at the left entries, 3, 1, 2, and 4 of each cell. Only the left entries. What we're going to do is find an entry that is less than or equal to another entry in the row. So we say, okay, 3 is greater than or equal to 1. That doesn't work. But 1 is less than or equal to 3. That works. 4 is greater than or equal to 2. But 2 is less than or equal to 4. So we're only looking in this column. Not only does it have to be less than or equal to in the row, it has to be greater than or equal to in the column. Well, 1 is less than or equal to 2. That doesn't work. But 2 is greater than or equal to 1. So we say we have a saddle point here because 2 is less than or equal to 4, and 2 is greater than or equal to 1. So we have a saddle point. And again, that shows each player what their optimal strategy is for maximum gains of one player and minimum losses of another player. After manually calculating all of the payoff matrices throughout my project, I started finding patterns in how I could create some type of formula. So if we look at the top first, every time we see an X naught, that is X's starting position, so here. Y naught is Y's starting position, so here. And X by itself is X's gain, so down here. And a Y by itself is Y's gain, right here. And we can say if we know what the starting position of X and Y are, with the X's gains and Y's gains, we can actually plug into this formula and figure out how to fill in each individual payoff matrix instead of manually calculating each number out. Now that we've seen an example and what the formula entails, now let's look at 3 starting positions with a certain set of gains for X and Y. So under the set gains of X gaining 2, Y gaining 3, the starting position of 3, 7, that provides an invade, invade saddle point. Under the starting position of 2, 8, we have another invade, invade saddle point. But under the starting position of 1, 9, we actually moved that saddle point from invade, invade to defend, invade. And if we were to go one further to the right, we would actually have the starting position of 0, 10, which that one will have a saddle point at defend, invade, as well as invade, invade, which we would like to call a double saddle point, which we will see in a moment. Now let's compare that to when we're not increasing X's gains, but we're only increasing Y's gains, and we're at the same starting positions. See what changes basically. So under the new set of gains, where the first one was invade, invade, now the second one of that is 3, 7 is also invade, invade. Comparing the first one at 2, 8 with an invade, invade saddle point, with the new set of gains, 2, 8 now has a saddle point at defend, invade. The first, under the first set of gains, 1, 9 had a saddle point at defend, invade, but now with Y increased, we now have a SATA point at defend invade and invade invade, like we just stated, where 0-10 will also have a double SATA point. After increasing the gains for Y, now let's increase the gains for X. So we're again going to look at the 3 starting positions and then compare them to an increase in X's gains. So let's first look at, well, we have a starting position of 3-7, and we have a defend invade SATA point. Secondly, we have the starting position of 2-8, and we have a defend invade SATA point as well as an invade SATA point. So again, another double SATA point. And as well, the starting position of 1-9, we have another double SATA point. Let's go further. Now we're going to compare the same starting positions to an increase in only X's gains but not Y's gains. So before, 3-7 had a defend invade SATA point, but now under new gains for X, we have another defend invade SATA point under 3-7. We go to 2-8, where before we had a double SATA point, but under X's new gains, 2-8 only has a defend invade SATA point. And we move over to 1-9. 1-9 had a double SATA point. New gains for X, 1-9 also has a double SATA point. After looking at the 2 slides above, we can start creating findings for specific gains for X and Y. So when 1 is less than X's gain, 3 is less than or equal to Y's gain, which is less than or equal to 7, and X's gains are always less than Y's gains. We have these findings, that all games have at least one SATA point. The SATA points for each game only occur in the defend invade cells or the invade cells. So we can say that they are always under Y invade. Third, the difference in Y's gains and X's gains is the number of scenarios with double SATA points, which start at 0-10. If we were to look at the gains for Y and X and subtract them, 3 minus 2 would be 1. That is the number of scenarios with double SATA points. If we look here, we do not have any double SATA points, we do not have any double SATA points, and we do not have any double SATA points. But like I stated earlier, there is one starting position to the right with a double SATA point, which makes sense since Y's gains always have to be greater than X's gains. Every single game will always have at least one scenario with double SATA points. If we look here, 4 minus 2 would give you 2 scenarios with double SATA points. This is not a double SATA point, this is not a double SATA point, but now we have one double SATA point, and the 0-10 would give you your second double SATA point. As we come back to our findings, number 4, finally, X's gains minus 1 is the number of scenarios where a defend invade SATA point is the only SATA point that occurs. Let's go look. If we look at X's gains of 2, 2 minus 1 is 1, so we should only have one scenario with a defend invade SATA point. Here is a defend invade SATA point, that is 1. Where here is a double SATA point and a double SATA point and then a double SATA point. So we only have one scenario with defend invade only. If we compare that to gains of 3, 3 minus 1 would give you 2. We should have 2 scenarios with only defend invade. We have a defend invade here only, a defend invade here only, and then a double. So we have 2 of those, so that matches. If I decided to go down a path of future work with this model, I could go into repeated play by basically analyzing one specific game with set gains for X and Y, and see how long it would take for y to completely gain all of x's units, because of the rule that states y's gains are always greater than x's gains. And I could basically start changing different rules, where the rule that states if a country's unit gain is greater than what's available, do not take anything, throw that rule out the window and just say take out whatever's available. Many things could happen there. Maybe not every single starting position has a setup point. That's something to look at.